Our final look at more measures of spread in your note is given by this example. So you'll see that there's a set of data here where there are 6 data points in 10 rows. And so one of the first things I want to identify is the fact that there are a grand total of 60 data points in this set. And because of the nature of their values, you might assume that maybe they are marks on a test, or final marks in a course, or marks on a contest. It could be anything along those lines. Because they do range from 35 up to 98, that would be a reasonable assumption. So what I've added here, again, are our 2 equations that are relating to percentiles to help us get a little bit more practice. But this time, instead of just working with 10 data points and puppies, let's work with a much larger set and to see how these equations apply in this scenario. So the first thing says what percentage, or another way of thinking is what percentile ranking is the score of 81. So the first thing we want to do is we want to identify where 81 is. And 81 is right here. What you'll notice in this data set is it's been arranged by columns so that you can figure out what data point this is out of a possible 60 by counting through the columns. So when we use the equation here to find the percentile ranking, we can say PK is equal to 100 times. First of all, we need to know how many data points are there ahead of the data point 81. So if we count by 6s, we have 1, 2, 3, 4, 5, 6. 7 times 6 would be 42. 43, 44. There are 45 data points ahead of that value of 81. Okay, plus a half times how many data points are equal to the value of 81. Well, there is only 1, so we can put a 1 in here, and then we can divide by 100. Or sorry, divide by the total number of data points. My bad, I was jumping ahead of myself here, which is 60. So if we do 100 times 45 and a half, out of 60, we get a PK value of 75.8. Now, we're not going to express the percentiles in terms of parts of percentage. We're going to go to the nearest percent. Let's remember from the previous video that we round up. Therefore, 76 would be the percentile ranking of 81. And we could summarize that simply by saying P76 has a value of 81. Or the 76th percentile has a value of 81. So let's try this a few more times with a few more examples. Let's go to 91 this time. So I find 91 here, and same process. I want to know what is the percentile ranking. PK is going to be equal to 100 times how many data points are ahead of 91. Well, maybe I'm going to work backwards this time instead of counting them all up. Let's go back from 60. So this is data point 60, 59, 58, 57, 56. There would be 55 points ahead of data point 91. There is only 1 data point that has a value of 91, so a half times 1 divided by 60. Fast forwarding, punching it into your calculator, you get a value of 92.5, which again, we're going to round up to the nearest percentile, which would be a value of 93. So again, we could say a percentile ranking of 93 has a value in this data set of 91. All right, let's try this again. Let's go to 53. Well, 53 is down here. The 53 is a little different because this time there are 2 of the data points that have a value of 53. So how will we accommodate that in the equation? Well, our PK value is still equal to 100 times the number of data points ahead of the value 53. So if we count them, there are 6 here, 7, 8, 9 before the first time that we see 53. So I would put a 9 here. Plus a half times, now this time, how many of them are equal to the value of 53? Well, 2 of them are equal to the value of 53. And I would still divide by the total number of data points, which is 60. So this time I have 100 times 10 over 60, which, fast forwarding in your calculator, comes out to 16.7. When rounded up, becomes 17. So therefore, the 17th percentile for this particular data set, again, if you take it all up and you were to divide it into 100 little pieces, the 17th piece would have a value of 53. Finally, let's look at data points that have a value of 62. Now we have to be careful because we notice that there's a whole group of 62s right here, but there's also one here as well. Okay, but nonetheless, same process. I'm just going to put it down here. The percentile ranking for data points with a value of 62, again, is 100 times the number of data points that are ahead of 62. Well, 6 and 6 would be 12, and another 5 would be 17. Plus a half times the number of data points that actually do have a value of 62. And this time there are 4 of them, divided by 60. So we get 100 times 19 over 60 this time, which comes out to 31.7, which when we round up comes out to 32, which means therefore the percentile ranking of 32 would have a value of 62 in this data set. And that's how we can use large data sets in cases where the data value is repeated to still calculate the percentile. Okay. Part B of this example asks us to find out what the value is in this set at certain percentile rankings. So let's explore how that works. So what score represents the 80th percentile? So this time we need to find out the value of the data point at the 80th percentile. So we can say that value is equal to the percentile, which is 80. And then we're going to multiply it by the total number of data points, which is 60, and divide by 100. As you can see, this equation is much easier to use than the other one. When you punch this all in, you end up with a value of 48 exactly. And so therefore, we can say that the 80th percentile in this data set has a value of, not a value of 48, but the value at the 48th data point. So we have to find out where that 48th data point is. And we're counting by sixes. So 6, 12, 18, 24, 30, 36, 42, and another 6 would take us to here. Would take it to this one there. So here's our 48th data point. Therefore, the percentile value at the 80th percentile has a value of 82. Because the one danger, even though this is an easier equation, is that you might think this is the final answer. It's not. It wouldn't make sense that the 80th percentile would have a value of 48. That would put it way over here. That's clearly less than half. Okay. Let's try it again. This time let's do the 96th percentile. So, same equation. This time we'll put in 96 instead of 80. We still have 60 total data points. Divide by 100. Let's find out what is the number of the data point that's less than or equal to the 96th percentile. When you punch all this in, you get 57.6, which again we're going to round up to being the 58th data point. Now, because we have 60 all told, I'm thinking it's probably going to be easier to work backwards than it is to work forwards. So if this is data point 60, this would be 59, this would be 58 right here. So therefore, the data point at the 96th percentile has a value of 94. And there you go. All right, to finish off this lesson, we have one more concept to learn about in terms of measures of spread. It's something called a Z-score. The Z-score is very predictable in terms of how to calculate it, but there's a little bit of work that goes into it. So you'll notice on your note that there are two formulas for something called a Z-score. And a Z-score simply measures the number of standard deviations that a datum is above or below a mean. So again, we're going back to using the mean as the measure of central tendency as opposed to median. And so what it means is that we want to see if we have a mean value here, how far away from that mean, how many standard deviations is a data point away from the mean. Obviously, we want data points to be as close to the mean as possible. The most that we will ever consider truly in this course is 3 standard deviations away. Once you get too much further than that, the data point becomes an outlier. Okay, so the formula for if it's a population that you're finding the z-score of is z is equal to the value of the data point minus the mean divided by the standard deviation for that particular data set. And we looked at standard deviation in the previous lesson. For a sample, it's very similar. It still says z equals. We still have the value of the data point, but we express the mean this way when we're looking at a sample as opposed to this way when we're looking at a population, and divided by the number of items that are in that sample, divided by s here. Sorry, not the number of data points, the standard deviation for the population, my bad. All right, so z-score is easy. If you know all 3 of these variables, you can just solve for the z-score. So in the example, we are given that mu is equal to 72.8. We're given that the standard deviation is 16.1. What is the z-score when x is 43 and when x is 76? Okay, so it's just a straight calculation of substituting into this equation. So in the first scenario, the z-score for when the data point has a value of 43 is just equal to 43 minus the mean, 72.8, divided by the standard deviation, which is 16.1. When you're punching this to your calculator, make sure that you simplify the numerator first before you do the division, or punch it in with brackets if you want to do it all at once without hitting equals before the division. Okay. When you do that, you should discover that the z-score is negative 1.85. Okay, and we're going to come back to z-scores a lot more in future units too. We're just sort of planting the seed of how they work here in this lesson. Similarly, the z-score for a data point that has a value of 76 in this particular data set, where the mean has this value and the standard deviation has this value, again, straight subbing in. 76 minus 72.8 divided by 16.1 gives a z-score of 0.20. So now you have it, everything that you need in order to finish your introductory study of more measures of spread. Enjoy your practice. If you have any questions, feel free to contact me.